All right, if you're gearing up for your operative dentistry exams, this one's for you. We are about to do a super fast masterclass on the core principles of amalgam tooth preparation. Let's jump right in.
Seems like such a simple question, doesn't it? But, the real answer to this is what separates a decent prep from a fantastic one. It's the absolute bedrock for everything else we're about to cover. And that brings us to our first critical topic, getting your depths right.
Before we even start thinking about walls or angles or any of that, we have to talk about depth. Honestly, think of it like digging the foundation for a house. If you get this part wrong, the whole thing is just compromised from the start. So what are the exact rules you absolutely have to know?
Okay, so your default setting, your go-to measurement, is always from the dentinoenamel junction, the DEJ. But, and this is a big but, there are two key situations where you have to throw that rule right out the window. First, if the enamel is already really worn down and thin. Second, if your prep actually goes down onto the root surface. In those cases, the DEJ just isn't a reliable landmark anymore.
So let's get into the specifics, the numbers you need to burn into your brain. For the pulpal floor, up on the occlusal surface, you've got two options. You either go 0.2 millimeters inside the DEJ, or you go a total of 1.5 millimeters down from the central groove. And the rule is, you always pick whichever one is deeper. That guarantees you have enough bulk. But look what happens when you move on to the root. It's a totally different ballgame. Here, you need a fixed depth, period, 0.75 to 1 millimeter deep. Why? Because you've got to have enough room for retention, which we're going to get to in just a minute.
And that same logic applies perfectly to your axial walls. The standard, no frills depth, is 0.2 millimeters inside the DEJ. But the second you decide you need to place retention grooves, you've got to go deeper, all the way to 0.5 millimeters. Now remember, that extra depth isn't for the amalgam. Nope, it's to create a safe zone for your grooves so you don't end up undermining that fragile enamel right at the margin.
Okay, so we've set the depth of our foundation. Now it's time to build the walls. We're talking about the cavosurface margin, that literal edge of your preparation. And here, the long-term success of your restoration really comes down to one magic number.
That's it, 90 degrees. This single number is the absolute cornerstone of a strong, durable amalgam restoration. It is the perfect angle for both the tooth structure you're leaving behind and the amalgam you're about to put in. Let's break down why. This perfect 90-degree meeting point has a name. It's called a butt joint. It's not a very fancy term, I know, but it perfectly describes the goal here. You want a straight, strong, shoulder-to-shoulder connection. No fragile, thin little edges of either material. It's a design that's just built for strength.
And here's the why behind it all. You have to remember, both enamel and amalgam are pretty brittle materials. So if you leave a really thin, sharp edge of enamel, those little enamel rods are just going to fracture off. And if you create a thin little fin of amalgam at the edge, it's just going to chip away under pressure. The 90-degree butt joint gives both materials the bulk they need right where it counts the most.
So a proper margin, one that's 90 degrees or even a little more, makes sure that every single enamel rod is sitting on a solid foundation of dentin. But if you cut that margin at a sharp, acute angle, you create what we call unsupported enamel rods. And that's just a fragile little ledge waiting to break off and cause the whole margin to fail.
Okay, we've got our depth, we've shaped our margins. Now we get into the real engineering part of the prep, resistance form. This is all about designing a restoration that can take years and years of intense chewing forces without cracking.
Now, pay really close attention to this definition. Resistance form isn't just about protecting the filling. It's also about protecting the tooth. It's a dual-purpose design. It reinforces what's left of the tooth while also giving the amalgam the bulk it needs to survive. And a huge part of that is simply amalgam thickness. You absolutely must have 1.5 to 2 millimeters of amalgam anywhere there's direct occlusal contact. That's where the forces are just massive. In the less stressed axial areas, though, you can get away with about 0.75 millimeters. So this makes it crystal clear. Bulk equals strength, right where it matters most.
Okay, for your exam, here is a fantastic mnemonic to remember the key features of resistance form. Just remember the word CRAFT. C is for conserve tooth structure, especially your cusps. R is for round your internal angles to spread out the stress. A is for adequate amalgam thickness. F is for flat floors that are perpendicular to the chewing forces. And T is for trim away any of that unsupported enamel. If you can craft your prep, you've nailed resistance form.
So if resistance is all about preventing fracture, retention form is about preventing the restoration from just
falling out. I mean, amalgam isn't bonded, so we have to literally lock it into place mechanically. Let's see how that works. So there are really two levels of retention. You have your primary retention, which comes from the overall geometric shape of your prep. It's just inherently stable. Then you have secondary retention. That's what you add when you need a little more grip, using specific mechanical features to create extra locks. The key to primary retention is making your walls converge towards the occlusal. The easiest way to picture this is like a classic dovetail joint in woodworking. The opening of the prep is just a little bit narrower than the floor. So once the amalgam is set, it's physically impossible for it to be pulled out. It's locked in just by its shape. But what happens if you don't have enough wall height to get that nice dovetail lock? Well, that's where secondary retention comes in. You can really think of these features, things like grooves, coves, slots, and pins, as the screws and anchors of dentistry. They are undercuts that you place on purpose to provide that extra mechanical grip, anchoring the amalgam down securely. Finally, let's pull all these principles together and connect them to the tools you're actually using every day. Because look, knowing what to do is great, but knowing how to do it efficiently, well, that's what makes you a master.
And this is where it all comes together beautifully. Those pear-shaped burrs you use, like the 245 and the 330, are designed to do two jobs at once. Their very shape naturally creates those occlusally converging walls for your primary retention, while at the same time producing the rounded internal angles you need for resistance. The right tool makes getting the ideal prep geometry almost automatic.
So, we've just run through the entire classic amalgam blueprint, but I'll leave you with this question. These principles of resistance and retention might feel a little old school, a little specific to amalgam, right? But how do these foundational concepts secretly influence the way you should be designing your bonded, modern composite restorations? Something to think about. Thanks for watching.